Hey guys, in this lesson we would understand how to solve right triangles using trigonometry. Let's say we're given a question in which we're given a right triangle, right angled at angle B, and we're given two side lengths of the triangle. One is AB as 3 cm, another is BC at 8 cm, and we're asked to find angle A to the nearest degree. So that means this is what we are looking for. Now we notice here in the question we are given side lengths, however we are asked to find the angle. So whenever we are given side lengths and we are asked to find out angle, or whenever we are given angle and we are asked to find out unknown side length, that means we have to use the relationship between the angle of the triangle and the side lengths of the triangle. And that relationship is called trigonometry. Now, in order to find out this angle, step 1 is to find out what is the relationship of the angle that we are looking for and the side lengths that we are given. And that relationship is finding which one is opposite, which one is adjacent, which one is hypotenuse. So step 1 is find the relationship between the unknown angle and known side lengths. Our unknown angle is angle A and known side lengths are BC and AB. For angle A, BC side is opposite to vertex A. Therefore, this side is the opposite side, and since angle A lies on side AB, so this side is the adjacent side with respect to angle A. Once we are done step 1 by marking these relationships on the triangle itself, step 2 is use the trig ratio that uses the relationship determined in step 1. Now the trig ratio that defines opposite and adjacent side for angle A is TOA. So what we do is we write on all three trig ratios SOHCA TOA, because SO requires opposite and hypotenuse, CA requires adjacent and hypotenuse. That means hypotenuse is required for writing the ratio sine and cosine, which is what we are not given in this particular question. So in order to find out this angle, we would use TOA ratio and we would rule out the options of SO and CA ratio, because in TOA ratio we have both the opposite side given to us, that is 8 centimeters, as well as the adjacent side given to us, that is 3 centimeters. So how do we use this ratio is we write on tan for the angle that we are writing the ratio for. So this angle is A. Tan A is opposite over adjacent. Opposite is 8. Adjacent is 3. Therefore, we get tan angle A is equal to 8 over 3. Because the question wants us to find out the measure of angle A. So A is our variable that we have to isolate. We'll keep A on this side and we'll move tan on the other side. If the trigonometric ratio goes alone on the other side without the angle, then it becomes the inverse ratio. So this tan becomes tan inverse of 8 over 3. In order to solve for angle A, we have to use a calculator at this point. In the calculator, we already have the keys sine, cos, and tan incorporated. However, if we want to find out the inverse values, then we have to press second function on the calculator, or some calculators have shift button, or sometimes second function is written as second like this. So we have to first press the second function or shift key or the second key on the calculator. That would convert our tan to tan inverse. Once we get tan converted to tan inverse, then in bracket we have to put 8 divided by 3. So we put a bracket and we put 8 divided by 3 and we close the bracket. And when we click equal to sign, we would get the answer from the calculator. And the answer that we would get would be in degrees, because this is the answer for the angle. So in this particular case, we got angle A as 69.44 degrees. As the question wants us to write on the answer to the nearest degree, that means we have to write on the answer to the nearest whole number. So that would give us angle A equal to 69 degrees. And this is how we solve the unknown angle whenever we are given sides of the triangle using trigonometry. However, we can only use these ratios if the triangles are right angle triangles. Let's take up an example where we have to find out the unknown side length in a right angle triangle. Let's say the second question we are given is this triangle in which we are looking for side X to the nearest tenth of the centimeter. Let's go over the steps to find out the unknown side length. How do we know that we have to use trigonometry in this case? Is we are given one angle of the triangle. This is the right angle triangle, and we're given one side of the triangle. If we were given two sides of the triangle, then we would have used Pythagorean theorem that you have already learned in previous grades to find out the unknown side length. However, since we've just known one side length of this triangle, we would not be able to use Pythagorean theorem, but we will be able to use trigonometry because we also know the angle of the triangle. So step 1 is to find the relationship between the angle given and the side length given, as well as the relationship between the angle given and the unknown side length that we are looking for. And in this particular case, for the given angle, the side that is given to us is the side opposite to the angle, so this is the opposite side. And for the same given angle, the side that we are looking for is the side on which this angle is lying, so this is the adjacent side. This side is opposite to 90-degree angle, so this is going to be hypotenuse. So once we have completed step 1, next is the step 2, and step 2 is to determine the trig ratio that will be applicable to step 1. So again, in this case, because the known side is opposite and unknown side is adjacent, so that means we have to use opposite and adjacent ratio. An opposite and adjacent ratio can be found out using tan of an angle. So in this case, therefore in this case, we would write down tan of angle 62 degrees is equal to opposite over adjacent. Opposite side is given to us as 27 and adjacent side is what we are looking for, and that is x. Now next step is just to solve for x, and how do we do that is, this is the ratio we have. We have to sub in the calculator tan 62 degrees. We do not have to press or punch in any second function key in this case. Just we have to click on tan button on the calculator. Along with that, we would type in 62 degrees on the calculator, and we would get the value for tan 62 as 1.88 is equal to 27 over x. Now to solve for x, we just have to isolate x. So x goes here and we get 27 divided by 1.88. We put this on the calculator and we get here x equal to 14.36 centimeters. Because the unit is given to us as centimeters. However, the question wants us to find the answer to the nearest tenth, that means 1 decimal place. So we would round the answer to 1 decimal place. Therefore, the final answer would be equal to x equal to 14.4 centimeters. Let's take up one last example for the sake of practice. So example 3 is, we are given triangle ABC where side AB is given to us as 19 meters, side BC is given to us as 27 meters, and angle B is given to us as 90 degrees. We're first asked to draw this triangle and label all the information. Second part is to solve triangle ABC. Whenever the question says to solve triangle, that means they want us to find out all the unknown side lengths as well as the unknown angles. So let's first draw the triangle and see what is our unknown, and that's part A. Because this triangle is a right angle triangle, right angled at angle B. This is how the triangle would look like. Side AB is 19 meters, so this is 19 meters. Side BC is 27 meters, that's this. We would be finding the unknown side AC that we have marked as x, as well as we will be solving for angle A and angle C. This completes our part A, as we have drawn the diagram as well as we have labeled all the information. Let's go over part B. Part B says we have to solve the triangle. That means we have to solve for side length x and we have to solve for angle A and angle C. As we see here in this particular right angle triangle, we know two side lengths and we are looking for the third side length. So we need not worry about using trigonometric ratios here. So what are we going to do is, in order to find out x, is use Pythagorean theorem. Now what is Pythagorean theorem? Pythagorean theorem says that hypotenuse square is equal to perpendicular square plus base square. As this side x is the hypotenuse, so we would write down x square is equal to perpendicular and the base. is 19 and 27 respectively. So we would put 19 square plus 27 square. 19 square we get is 361 and 27 square is 729. X will be equal to 729 plus 361 square root, that is 1090 square root, which is equal to 33.01. Because this is given to us in meters, so this would be in meters as well. As we are asked to express the length to the nearest meter, so we would round the answer to whole numbers. Therefore, x value is equal to 33 meters. This gives us the third side length of the triangle. Now the next part is to solve these two angles. As we have to find out the angles from the side lengths, now we have to use right angle triangle trigonometric ratios because we need to use the relationship between the angle and the side lengths. Let's now put this x as 33 meters and remove x from there because we know the value of x now. We will solve for angle A first. It's up to us. We can even solve for angle C first. So in this, here we are solving for angle A first. In order to find out the angle A, we need to find out the relationship between angle A and the known sides. This is angle A. With respect to angle A, this side is opposite and this side is adjacent. Hypotenuse stays hypotenuse, no matter which angle we are considering. Now, as for angle A, we are given all three sides. That means we know all three ratios. So, ka to because sine of angle A would be equal to opposite side over hypotenuse side. That is what we know. As well as if we try using cosine for angle A, we would need to use adjacent side over hypotenuse side. Again, both we know. And if we use tan ratio for angle A, then we need to use the opposite side and adjacent side. So as we know all three sides, we can use any of these three ratios. We have already used tan ratios in the previous example, so let's practice using sine ratio in this one. We'll write down sine of angle A is equal to opposite over hypotenuse. So opposite is 27, hypotenuse is 33 that we have found out when we found out the value of x, is equal to sine A. Because we are looking to find out the angle A, we would isolate angle A and we would move the sine on the other side. When sine moves on the other side, it becomes sine inverse of side length 27 over 33. All we have to do is just put this in the calculator. So we first click on second function such that sine turns into sine inverse, and then in bracket we would put 27 divided by 33 and that would give us angle A as 54.9 degrees. As the question wants us to write on the angles to the nearest degree, so we would round this answer to the nearest whole number. Therefore, we get angle A as 55 degrees. And this is how we get angle A as 55 degrees. Next we have to solve is angle C. To solve for angle C, we can either use trigonometry, as we can use the relationship between angle C and the sides known, or we can use angle sum property of triangles. Because this is easier to use, so we would opt for angle sum property of triangles, and that is angle C is equal to 180 minus the sum of angle A and angle B, because the sum total of A, B, C is 180 degrees. Angle A we have got is 55 degrees. B we know is 90 degrees. 90 plus 55 is 145 degrees. So 180 minus 145 degrees would give us 35 degrees. Therefore, this angle C is 35 degrees. And this is how we get all the angles and all the sides of the right angle triangle using trigonometry, Pythagorean theorem, and angle sum property of triangles. Therefore, we can conclude to solve right triangles, we can use trig ratios, Pythagorean theorem, and angle sum property of triangles. Either we can use two at a time or all three combinations. That depends upon the type of question that we are given.